Hello student, the question says the equivalent resistance of series combination of two resistors is S. When they are connected in parallel, the equivalent resistance is P. If S equals to NP, then the minimum value for N is. Okay, let us try to solve this problem. So let us assume two resistances R1 and R2. So when they are connected in series, so we can write S equals to R1 plus R2. And when they are connected in parallel, we can write R effective is R1 R2 by R1 plus R2. Now the author is saying the equivalent resistance P if S equals to NP. So he is saying S must be equals to N into P. So R1 plus R2 equals to N times R1 R2 by R1 plus R2. Now let us get an expression for N. So N equals to R1 plus R2 whole square divided by R1 R2. Now let us expand this. We will get R1 square plus R2 square plus 2R1 R2 divided by R1 R2. So we'll get N equals to R1 by R2 plus R2 by R1 plus 2. To solve this problem, we need an expression for N. But here we got N in terms of both R1 and R2. So let us reduce it to a single term. So let us assume R1 by R2 as some letter X or something like that. So N would become X plus 1 by X plus 2. Now we got an expression. Once we have an expression, we can find what is the least possible value for X, or what should be the value of X so that N is minimum, because the author is saying the minimum value of N. So we will use maxima minima rule. Maxima or minima rule. What does the maxima minima rule says? First step is you will differentiate it with respect to its variable and equate it to 0. So we got N equal to X plus 1 by X plus 2. So if you go for d by dx, you will get 1 minus 1 by x square plus 0, and let us equate it to 0. So you'll get 1 equals to 1 by x square, and with this you will get x is equals to plus or minus 1. And we know resistances are always positive as we deal for given case. That means usually in current electricity and all that, we'll assume the resistances are always positive. So based on that, the ratio of those resistances, because X represents R1 by R2, it should always be positive. So we can write R1 by R2 equals to 1, which implies R1 would be equal to R2. Once we got R1 as equals to R2, we can find even the value of N also. But we need to check whether this one would give us maxima or minima. To check that, we have to again differentiate it. That means we have to again differentiate this expression with respect to X. This is how we represent it. If you differentiate one, you will get 0. It would be minus 2 x power minus 2 minus 1. So you will get 2 x power minus 3, that is 2 by x cube. And we know since x would always be positive, this value would always be greater than 1. When you double differentiate it and you get greater than 1, that means previous result will give minima. What do I mean by that? Okay, it means at x equals to 1, n is minimum. That is, R1 must be equals to R2. If I substitute all that, we'll get n equals to 1 plus 1 by 1 plus 2. So 4 is the least value of the n. So the correct answer for this would be n value must be equal to 4. But remember, most of the time, whenever maximum minimum is involved in current electricity and we have two equal resistances or two resistances, they will always become equal after solving everything. So it will help you to solve the problems where the differentiation is slightly complicated also. Usually in current electricity chapter, whenever two resistances are there and maxima minima situation is involved, both the resistances would be equal. Okay, hope you understood how we actually solve this problem. Thank you.